Hello everyone, my name is Asif Mehmood and this is a project that me and my professor did. So the topic is related to vehicle location prediction, and we improved the accuracy of location that's necessary for the connected cars use case. If you see here, these are the use cases applications that require higher accuracy vehicle location and collision warning systems, enhancements.
Sorry. Yeah.
So these are the areas for which were the motivations to improve the accuracy of location. So according to the ETSI standards, these are the APIs related to connected car and the vehicle and other kind of devices which can share locations with each other. So these are the standards that provide insights for much further information about the location, and active device location tracking is the main target of this work. And this is the Kalman filter model, which is used to predict and estimate the GPS-based location, and in vehicles it's widely used. And if we see here, there are enhancements that can be made in this area. So what I did was that the main idea is that if we see here, the black lines are the road lanes, and vehicle is obviously has to move on these lanes, and in real they are. But what Kalman filter does is sometimes predicts the location offside the road, and which needs to be rectified and placed because the vehicle in actual is on the lane, not on off the road. So this is what I call rectification of the predicted location by Kalman filter. So for that I had to do some kind of experimentation and collect data as well. So I did all these things in my work, and these are the algorithms that I used. And for the coordinates, I used real-time coordinates like geo coordinates. So for that, I had to collect the map, the road structures, and the development of Kalman filter according to the rectification process that I designed. So here we see the first step of measurement, updates come along, and then prediction is done with the help of Kalman filter. And over these predictions, the rectification process is applied, and then we can compare these values, and we can expose this to the MEC host, which can be shared with other vehicles nearby if needed. So this is the vTrackia store that contains the map information and develops the relationship between the vehicle location and the road entities. For collecting these entities data, I used the open source website map provider, OpenStreetMap. And for experimentation, I did all these on Ubuntu and Python language and Jupyter. If you see here, the predictions on the sharp edges are not located onto the road lane. So this is a vehicle trajectory. So where we can see on different speeds and variations and locations, the predictions are not on the road. But if you see here, the predictions and the rectifications made over these locations are exactly mapped onto the road. So visually we can see here, but for numerically, I compared these results with the prediction basic Kalman filter predictions and rectifications. The RMSE tends to be lower than the predictions, and the error is low as compared to the Kalman filter prediction. So here the experimentation was done in over different speed ranges of vehicles like 50 to 60 kilometer per hour, the prediction error was this much, and it's greater than the rectification process if applied. So this was the work that I did, and if you have any questions about this, thank you.
I didn't get it, but what is the usage of the prediction?
To improve the accuracy of the prediction,
Yeah.
actually the vehicles need to share their real-time location for different use cases that I mentioned in the first page. Like here, collision warning systems can use these locations, or the nearby vehicles can also use this type of location prediction for solving different problems.
Actually, to anticipate problems. It's to anticipate the problem.
Yes. Yes. Share the location which use this location. Like, so these are the use cases that were the motivation for improving the.
Yeah, but why don't we use the real-time position then? Why don't we use the real-time position?
Real-time position.
Yeah.
I'm using this because Kalman filter is used over GPS locations, and applied the rectification mechanism because it's used for moving objects widely, and its accuracy is the computation is done inside the vehicle. It's faster. I
Okay,
think.
I see. So because you cannot use it, you cannot use a real-time position because since the object is moving,
Yeah.
by the time it's there, it's too late. So you need to predict where it's going to take action.
Where it needs to be provisioned, like the vehicle is kind of autonomously calculating and doesn't need any outsource like central system like distributed or something. So it can directly share its location with nearby vehicles. So maybe if we see here the vehicles nearby require for accidents. So any questions? Okay, thank you.